All right, so here we are, and it's Tuesday. Guess what? Depending on how you celebrate the holidays, Christmas is on Saturday, so that's going to be fun. So welcome. And yesterday, just to recap this just a little bit, is that we started off the day kind of connecting around architecting fundamentals, right? Talking just briefly about the well-architected framework, about how we use, APIs basically to talk to software-defined infrastructure. And, we're, also using either the web console, which is, you heard me refer to that as the console yesterday, but the web console, which requires a username and password. Then we're using either APIs via command line or APIs via software development kits, which are just really libraries that you import into your software stack. And those require access keys and secret access keys to function. Now, all of those are IAM kind of security credentials. And I did mention that, by the way, that there's a different way that we log into EC2, like virtual machines, and we use something that's specific to EC2. Does anybody remember what we use to log into EC2? Because we don't use IAM, not by default.
The PIM file?
That's right, PIM file, or PPK if we're using PuTTY, right? And those are basically variations on key pairs, right? So asymmetric key pairs. So we use those in order to log in, right? So, a variation on cryptography, right? To get access to these systems. The public key goes on the boxes we're logging into. We have the private key. I tend to think of the private key as the actual key and the public key as the lock. But just to be clear, they can both encrypt and decrypt to each other. So it's, it's not one-sided, right? So we talked about, those aspects, and then we talked about the core service that's actually used to manage users, groups, and roles inside of AWS, which of course the Identity Access Manager, which is IAM. So Identity Access Manager is the service that we use. You may remember that you can hook IAM into Active Directory or into any system that supports a particular protocol. And I'm not looking for OIDC, but what's the name of the markup language that you need to support in order to hook your identity system into IAM? Does anyone remember the name of it? Yeah, SAML 2.0, right? So security assertion markup language version 2.0, going to support that. Now, when you hook that in, just to say this, you create a trust relationship. There's a service that Amazon has that will actually help facilitate these trust relationships. So you can just sign on one place. Does anyone know the name of that service? Vinod, first of all, kudos for even mentioning STS, because that's the secure token service. And that is the service that underpins all of the integration. So if you're integrating with Active Directory or you're integrating, the secure token service is the one that does that. So kudos for even mentioning that, but that's not the answer that I'm looking for. It actually is single sign-on, right? Single sign-on is the one that helps facilitate all the trust relationships. So that's how you navigate that. Now, I mentioned that when you create IAM policies against users, groups, and roles, you can assign policies, and these are policies that are assigned to principals. Now, these are not resource-based policies. What are the name of these policies that you actually assign to users? What kind of policies are they? They're not resource-based policies. What's the other option? Good, Andrew, good. Identity-based policies. So identity-based policies are the ones that you actually attach to, like IAM principles, such as users, groups, and roles. Perfect. Now, if Amazon comes to you and says, I have a Python application sitting on an EC2 instance, and I need to grant access for that Python application to talk to DynamoDB and S3, which of the three principles are we going to use to grant that system access to DynamoDB? We're going to use a user, a group, a role, federated identity. What are we going to do? Good. Yeah, the answer is always a role because remember, if Amazon comes and asks you a question and they distinguish between permanent access rights and temporary access rights, which of those two does Amazon associate with a role? Permanent or temp? Which one? Good. Just make sure that stays there. That's just the way Amazon thinks about it. And I agree with them for the most part, right? Because you got these resources coming and going and they get roles assigned to them and the roles go away, but they're not keeping a permanent username and password, right? So that makes sense. All right, let's say it's 2018 and I've just walked into an organization that has over 700 AWS accounts because I am now the global architect for container and cloud. All of that's factual, by the way, that did actually happen. And there were 700 AWS accounts. What did I recommend that they do right away in order to actually apply both consolidated billing and security policies across all 700 accounts? No, but that is funny. No, organizations, right? So yeah, AWS organizations is what we're going to use, right? And now there's a variation of organizations, which includes organizations where you can apply a best practice like set of policies to your multi-account structure. Amazon has a product for that, right? And it's basically where you start if you're an organization and you want to create a multi-account best practice vending machine. What is that called? What was the name of that little one pager that we had? It wasn't called landing zone. It wasn't called organizations. Christian, good. You got one part of it, right? That's perfect, right? It's control tower. So control tower allows you to initiate account instantly into best practices for AWS. Okay, good. Now, control tower covers account security. So let's say that we want to apply some guardrails that actually prevent someone from using quantum computing in all of the accounts. What is the name of that structure? Because it's not an IAM policy, because IAM policies only work at an account level. What's the name of the policies you can set at an organization level that can prevent someone from launching a service? That's right, service control policies. That's literally what SCPs are, right? They're service control policies. Now, Heather, you are technically correct, by the way. You can't actually deny people access through resource-based policies or identity-based policies, but those operate at an account level. So they operate against the service in the account. SCPs operate at an organizational level against the accounts. So technically correct, but we're looking for the bigger one. Okay, now switching over to networking. If I want to go in and I have nothing in my account and I want to create my first thing that's going to create a networking segment, a networking boundary, what is the name of that first networking boundary? Good, VPC. Heather, I'm sorry. I hope that wasn't meant to be offensive. If I did, I apologize. It wasn't meant to be a touche. So VPC, right? So virtual private cloud. Good. Now, inside the virtual private cloud, what is the name of the next subsegment that you're going to create to subdivide that VPC? You know, I tried so hard not to use the word sub there, and I used it twice, like in the setup. Craziness. Anyway, subnet. Okay, good. Now, typically when I want to assign or set up a subnet, I have to assign basically what's called an IP range. Give me the first number of the three ranges that I am allowed to use from RFC 1918, which says these are private IP addresses for IPv4. So 10 is one. What are the other two? 172 is another one. What's the last one? It's actually really popular. It's probably the one people know more because most of our home networks use this. 192. Good. Yeah. So 10 dot whatever, 172.16 to all the way up to 172.31 if memory serves correctly, and then 192.168 is actually the full octet of the one, right, for RFC 1918. And it gets more specific. So 192.10 and then all the way up to 172.16 0.0 to 172.31.255. So 255. Christian just posted it. There we go. Cool. All right. So I've got a VPC. I've got a subnet. So now I want to talk to the internet. What do I need to add to the VPC to make that happen? All right, Timothy. All right, good. I see that you guys are using the shorthand. What does that stand for? Internet gateway. Good. Yeah, so internet gateway. If I am using IPv6, not IPv, not just IPv4, but I've added IPv6, IP version 6, and I want to get out to the internet. What do I have to add to my VPC? Good. Egress only internet gateway. Good. Okay. So let's say I want to take one of my private subnets and I want to make it public. And I want to basically take my internet gateway and somehow connect it to this private subnet so I can make it public. What do I have to change if I want to directly make it available to talk to the internet? I don't want to use a proxy, because you guys are giving me proxies right now with the NAT gateways, which is great. I'm glad you're thinking that way. But if I want to convert a private subnet into a public subnet directly, so it can talk directly to the internet, I have to modify something on that subnet. What do I modify in order to connect the internet gateway? Perfect. Yeah, Timothy, the route table. So remember, the only thing that makes a private and a public subnet different is whether or not I can talk directly to the internet gateway or I can't. And that only happens through the route table that's associated with those subnets. If it's a public subnet, I have a route that says I can talk directly to the internet gateway. If a private subnet, I do not have a route to talk to the internet gateway. Okay, true or false? By default, all subnets in a VPC can talk to each other. True or false? Yeah, so the next time we're in a lab, go look at the route table, right? The route table, if you notice, has all VPC traffic as being local. So by default, all subnets can talk to each other. If you want to change that, you either need to change the route table or you need to enable the NACL firewall, right? The one that governs the perimeter of a subnet, right? You got to turn that on. It is on, but it's not doing anything. Okay. All right, let's go back to a previous set. Let's say I'm on a private subnet and I need a proxy for outbound traffic to get to the internet because I don't want to convert that private subnet to public. What's the name of the service I'm going to enable in order to make that happen? All right, here's a little bonus question, because I see you putting that up there. By default, not including data shoved through a NAT gateway, how much does it cost per hour for you to have a single NAT gateway device up and running? Masood, yes, that's exactly right. Please be mindful of that, because NAT gateways are availability zone specific. So like internet gateways and egress only internet gateways are attached to a VPC. Those are region specific. A NAT gateway is availability zone specific. And so people get tempted to run 2 or 3 of them. And guess what happens? You start paying $2.40 a day. All of a sudden you're running 15 subnets. You can do the math because you got 5 VPC. Anyway, just be careful of that. There's like little nickel and dime stuff like that that starts to stack up when you start to get into dozens of those instances. Okay. And I really want you to know that also, because if you decide to run your own account, I want you to be mindful of the costs. If you decide to run a NAT gateway, you're going to pay 10 cents an hour. You're going to be like, I spent $10 to run a world-class enterprise infrastructure. Okay. Last 2 questions. Well, maybe more than 2, actually. I reserve the right. So let's say that you decide that you're going to use a 10 network, and actually let's switch that. You're going to use a 192.168.1. It's a /24, which means the 192.168.1 is actually the designation that says this is the network. And that last number that goes from 0 to 255, that is actually going to be your subnet, right? And so that's where the hosts are going to go. By default, how many IP addresses does Amazon take from your subnet, not your VPC or your subnet? Yeah, good. And Christian, I really like that. So you all answered it correctly. Christian, I like that. So the first and last are going to be taken because those are taken by the network. It's actually not an Amazon thing. That's just what happens when you define a subnet. But then you lose the first 4 because Amazon's going to take the first 3 in the range after, well, the next 3 in the range after the first one. So it's really total of 5. So the answer is totally correct, but you're going to lose the first 4 and then and the last one's going to be gone. Just so you know, the first one and the last one are taken because the first one, if something broadcasts into that first one, it says this network, like this specific network. And if you broadcast on 255, it says I'm talking to everybody across the entire network. So those IP addresses are reserved. The first and last one of any subnet has means of talking to everything on the network and then talking to the network itself. So I know that sounds weird, but just roll with it. That's actually a TCP/IP thing, or an IP thing, really. So, all right. So if I come in, let's back up to the VPC for a second, and someone says, hey, I want to run a /15 for my VPC. Your answer to them would be, yes, you can, or no, you can't do that. Okay, good. The answer is no, because /16, right, is the largest. I know that's a low number, but it's the largest you can run. If someone comes to you and says, hey, I want to run a /28 for my smallest network for my VPC, is that allowed? Good. A /28 is indeed, yeah, it is silly, right? It is indeed the smallest network that you can run. Okay, so /16 to /28 is the range for a VPC, right? That'd be weird to try and subnet that, right? Would that be a VPC with one network inside of it? Anyway, moving on. So, all right, if I want to turn on a firewall that basically is stateful and wraps itself around the instance, what firewall do I need to mess with? What's the name of that firewall? Okay, what's the name of the stateless firewall that wraps around the perimeter of a subnet? Good. If I want to deny a particular IP address in Colorado who keeps trying to hack my web server, am I going to use a NACL or am I going to use a security group? Right. Remember, NACLs are the only ones that can deny a specific range. I'm not saying security groups can't deny everything, but security groups cannot deny a specific IP range per se. They can only allow traffic. Otherwise, they deny everything. Right. So imagine if you're trying to deny the guy in Colorado with a security group, you'd have to create an allow list for every single other IP address in the world. Right. That would be really weird. So you're not going to do that. Okay. Which one of these, either the security group or the NACL, requires you to have just one rule for both request and response? Good. One rule for request or response. In other words, if I want to talk to somebody on port 80 and they run to a random port and then they're going to respond, I only need one rule for a security group because the security group is going to track the connection. NACLs, you need two rules for request and response. So for a single exchange, you need two rules, right? Good. If I want to put a bunch of servers into a particular grouping and then have a firewall only allow traffic from that grouping, which of the things do I need to use? Which of the firewalls? Nope, I can still use the security group for that. Shan, so just so you know, like I can actually put all the app servers into a security group called app server security group, and then have it so the database security group will only accept connections from the app, from members of the app security group. So you can chain security groups together so you only respond to members of those security groups. Okay, that does actually lead to the next thing though, right? Which we have barely talked about. If gateways, NAT gateways are for outbound traffic, then load balancers are for inbound traffic, right? So we haven't even talked about load balancers yet, so I'm not going to ask you any questions on it, but just know that load balancers are for inbound traffic, NAT gateways are for outbound traffic, right? Particularly when you want to get in and out of a private subnet. Good. Okay, a few more questions. We're going to switch over to EC2. Okay, so if I say that I want to run a C5 extra large, what does the C stand for in that particular equation? What kind of design does that represent? So C for compute, right? If I say I want to run an R5 series, what does the R stand for? Memory, RAM, perfect, good. Yeah, that's the memory class, right? If I say I want to run a G or a P series, what class of EC2 instances is that? A G or a P series? So I want to like a P3, for example. So remember, M is for median, right? G and P is for GPU, right? So that's graphics systems. Now, those are systems that you wouldn't necessarily game on. Not that kind of GPU. I mean, it is actually, but regardless, it's GPUs that are designed for number crunching. People hear this all the time and may not remember, but like these are GPUs that are optimized for hashes. Like this is what people are using. By the way, video cards are short, not because of Bitcoin, which doesn't use GPUs to mine. It uses ASICs, which are specially designed for Bitcoin. But the problem is that all of the altcoins out there, like, you know, Shinu and Dogecoin, Ethereum, all that, they're the ones that use the video cards up. So just so you know, that's why that. And for example, you could actually use some of these systems for Bitcoin mining, as an example, but mainly it's for data hashing. Okay, so those are the general family types. If someone comes to me and says, you know what, I have really stringent security and licensing requirements, I cannot run in shared tenancy, what kind of options do you have in AWS? Good. Now, I'm gonna tell you something weird. Dedicated host gives you a big, like huge host that you can actually run virtual machines on. A dedicated instance is where they actually stick you on a machine that is perfectly sized for your virtual machine and nobody else is on it. Isn't that weird? Does that mean that Amazon just has like a section of their data center that's full of just a bunch of tiny like machines? And so when you decide that you want to run a T3 micro and dedicated, they just put you on a tiny little 1 processor 2 gig box that has its own. Isn't that strange to think about? That's what dedicated instances are, by the way. Okay. If someone comes to you and says, look, I have an application that can withstand interruption and I'm running a report that isn't due until like 30 days out, which of the like licensing types are you probably going to explore? Good. Excellent. Someone comes to you and says, look, man, I got a project that's going to run for 3 years and we know it's going to be steady state workload and we have to run in US East 1 and we know which data centers we're going to use and we're going to be running Linux. Good. Steady state workload, right? 3 years. That's going to be a reservation. Good. Someone says, you know what? We don't know if we're going to use Lambda, containers, or compute, but we'd like to get a discount, maybe up to like 50% from Amazon. Are there options for me to do that in order to be able to run like the compute that I want? Perfect. Good. Compute savings plans. All right, what is the 3-letter acronym for the way that you choose the operating system and affiliated disk drives for EC2? All right, bonus points. What was the name of the tool that I recommended you use instead of the hot dumpster fire that I call the EC2 image builder? It's made by a company called HashiCorp. Yeah, good. Packer. Yeah, Packer's actually really easy to use if you understand how the operating system you're using works. Okay, cool. Now the EC2 image builder is okay. It's going to get really good really fast, but right now it's not awesome. So just don't use it. And honestly, if you already have Packer, why would you be looking at a new tool anyway? Anyway, moving on. Just ignore me. Okay, so someone comes to you and says, hey, I need to basically archive a bunch of my database logs onto a disk. And it doesn't have to be very fast, but I can't put it on S3. I just want to stick it on a disk attached to the system. What flavor of EBS disk are you going to use if someone wants cold storage on a disk? Cool. You are definitely going to use mechanical. Now, out of these two options, ST1 or SC1, which of these is built for cold storage? Good. Okay. By the way, the other one is for streaming throughput. So one is for super cold storage. The other one's for streaming throughput. So ST1 and SC1. All right. Someone comes to you and says, hey, Michael, I need to run a high throughput database workload on my EC2 instance. What kind of drive should I attach to that instance? Good. Excellent. IO1 or 2, preferably IO2 from my perspective, but honestly, either will work. What if somebody comes to you and says, Michael, I need 200,000 IO per second on a provision drive? What is the name of the super flavor of IO2? Because it's just so you know, 200,000 IO per second is ridiculous. Multiply that times 256K and you know, you kind of get an idea of what the max throughput is. That thing shoves 4 gigs a second through the drive. All right. So the name of that is called IO2 Block Express. Relatively new flavor, right, of disk drive that just came out. For the rest of us who are just using standard, like random IO workloads, what is the standard disk drive that 99% of us are going to use on top of our systems, right? Yeah, we're going to use general purpose drive. So GP3 is the preferred. You could use GP2 if you wanted to, but GP3 is the preferred. Excellent. Cool. Okay. I have a bunch of other questions that I want to ask, but well, actually, let's talk about this. So if EBS is the persistent storage option available for AWS for EC2 instances, what's the ephemeral one that's available for EC2 instances? The one that comes for free. Good, instant storage. By the way, that comes in a variety of flavors. So sometimes it's mechanical, sometimes it's solid state, sometimes it's, you know, the high-end NVMe, you know, SSD, right? So just be mindful that check sure your instance type. You don't always just get high performance disk at that point. Okay. When we were talking about high performance computing yesterday, I mentioned that there were two other kind of types of networking above elastic network adapter, or sorry, dang it, I just gave one of them away. So above elastic network interfaces and above elastic network adapters, what was the highest, like 400 megabits a second, right, network card that you could use? Yeah, so elastic fabric adapter. Good. Good. All right, now out of the three placement types, right, where you've got, you know, cluster, spread, and then partition, which is the one that's going to give you the best throughput because it's going to put all the systems on the same physical host? Good. Which one is going to give you the most resiliency and redundancy because it's going to make sure that none of your systems sit on the same host? And what's the weird one that seems to be like a hybrid, but you're still going to be in the same availability zone, but it's going to let you spread across, you know, multiple hosts? Good. Excellent. Okay. All right. Sounds like a pretty good, you know, obviously there's other things I could ask questions about. Anybody actually have any questions about anything that we covered yesterday?
I think so. One question I have is that when we, once you start with a side range for a VPC, and let us say I want, you know, 3 subnets in that VPC.
Mhm.
How can I equally divide the, you know, IP ranges of that VPC? That wasn't very clear to me.
Well, for example, if you decide you're going to do a 10.0 or 10.1, for example, and let's say you end up with 65,000 addresses, right? You would just do the math on how you would subnet that out, right? In other words, you would pull out a subnet calculator and just figure out how to subnet, you know, you could divide, let's say that each one got, you know, as an example, 20,000 IP addresses. You would just figure out which of the subnet masks would get you those 20,000 IP addresses. Right.
Yeah. So I think the question is basically then, how do we pick the mask? How do we pick those numbers? And I guess that's the question is.
Yeah, so you're probably looking at, like, let's say, for example, a /24 is going to get you 256, right? So a /23 is going to get you 512, a /22 is going to get you 1,000, a /21 is going to get you 2,000, right? A /20 is going to get you 4,000, a /19 is going to get you 8,000, right? And so you just kind of keep going back on the mask until you get to the number of IP ranges that you want, right? And so, or you could just go grab a subnet calculator. That's IPv4 networking. That would take, you know, about 30 minutes to an hour to actually explain accurately to figure that out. But the bottom line is that you're just going to go grab a subnet calculator and say, I want to subdivide this into 3 networks. And then you would just put that into the subnet calculator, right?
Is this something, sir, available on the internet? Like,
Oh, yeah,
oh,
yeah, absolutely. As an example, let's go take a look. IPv version 4 subnet calculator. There's going to be a bunch, right?
Oh, nice.
And then you can just go out. Yeah, because this is a thing that's haunted people for a long time, right? Right. And so, for example, if you wanted to come down, let's say a 19, because that you figured out that a 19 is going to give you, let's say 8 or 16,000. I can't remember off the top of my head, but that's what you would do is you would figure out what the number, the subnet is that you wanted, and then it would basically calculate against the range that you were looking for, right? So this one's not super advanced, but like I would probably find one that has a little bit more options to it. Like this would be a good one, right? So let's say we're going to do a 10.0. And let's see, let's do a B here because we're doing, right, a /16. So there's 16 mask bits. And so this would give you basically the full range. Oh, that's right, because it switched over to 172. Let's do this instead. There we go. Switch to 16. So this would give you the full range if you were like doing the VPC, for example. But let's say that you were like, hey, you know what? I'm actually looking for something a little different. Let's say I needed, 16,000 hosts per subnet. And then what you're doing now is that you're at a /18, right? So this is the kind of like math that you would end up doing as a network engineer to figure out how to like divide up your subnets within that particular pie. So this is what you would do is you would figure out exactly what subnet mask to use. And then that would give you your starting and ending ranges. So like in this particular case, notice a 10.0.0.1 to a 10.0.63.254. So that would give you your host address range. And so then you would do that for the next one and the next one and the next one. So they give you the way that you would divide up your VPC.
Thank you, sir.
Yeah. If it seems like it's not that easy to grasp, just like at face value, it's because it's not. It isn't, right? Which is why we go to these calculators, because most of us have probably seen this like 3 or 4 times, right? And have probably like learned it, the XOR, the binary masking and all that. And we all end up at calculators because unless you're a network engineer, you're not doing this all the time, right? So I'm sure I'm not the only one, by the way, who's probably seen this at least 3 to 6 times and probably learned it, forgotten it, and then just you default to the calculators to figure out how IPv4 works, right? So bottom line, make buddies with a network engineer.
Thank you.
Yeah. And just to say this though, is that not a lot of people have spent the time to learn how IPv6 works, and we're going to, because IPv4 is going to fall out of favor here over the next couple of years. So people are going to be doing more IPv6 networking. So probably spend some time learning how that functions. Okay. Other questions? All right, we're going to switch into this weird mode for a second because PowerPoint. So I apologize. It's not going to be super full screen, but I'm sure we'll figure it out here in a bit. Every time I go full screen, it crashes. So I'll try and fix it during our next break. Okay, so check-in question was basically like, we're going to talk about storage. This is the next conversation. Now, we've already had a little bit of a conversation around storage already, right? We talked about block storage. So for this next set, right, what we're going to trying to find out is which of these statements are actually true regarding block and object storage. So take a stab at this and let's see. What do we know about block versus object storage? Well, here's the funky thing. All of these above are true, right? So here's the deal. Block storage is basically disk storage that works exactly like us hooking USB drives up to our system, right? So that kind of storage is useful for when we want to take a file, store it onto a hard drive. That hard drive is partitioned into discrete blocks. And so if we write a 4K file and the blocks are 1K, we've taken up 4 blocks because there's 1K a piece, right? If I update the end of that file and the only thing that's changed is that 4th block, it's just going to update the 4th block. It's not going to update all 4 blocks. That's what block storage does. Takes a disk, usually either attached directly or through a network, overlays a file system on it. That file system has some alignment and some checkpoints and some partitioning into it. When we write a file, it writes the blocks that are inside that checkpoint. Now, what's interesting is that object storage is different. Object storage says, here's the pointer. I'm going to dump the entire file into that pointer. I'm not going to use a file system on the surface to actually track all the discrete pieces of that file. I'm just going to make it one big blob of data. And so when you want to update that file, you go to the pointer and you re-upload the entire file. If you want to pull it, you re-download the entire file. So object storage doesn't take a single file and break it into discrete blocks or chunks that can be updated independently. Object storage takes the entire object, stores it at a reference pointer, and when you want to change it, you got to pull the entire object back, right? And then upload it back to the system. So this is a little different than file systems. Even though it looks like a file system, it's actually not. So S3 looks like a file system hierarchy, and it's really just a database for binary objects. That's an oversimplification, but you get the general idea. So when we talk about block storage, we've been talking about that with EBS and with instant storage, right? That block storage is the storage that we use for hard drives, right? That's what we do. Now, file storage is a variation of block storage, but the difference is that instead of operating at a low level, like plugging your USB drive in, you're connecting to a server that's on your network. And that server is feeding out that disk using a special protocol, either NFS or SMB CIFS, whatever we're using there. And then that is just a variation on block storage that's going across the network. That's all file storage is. And then object storage is exactly what we just talked about. You shove a file of some type into a system with a key pointer reference, and it's got a bunch of metadata associated with it. Is this file a web file? Is it a video file? Is it a JPEG? So just know that with object storage, you actually also associate some metadata and some attributes to the data itself. So let's talk about that in a little bit more detail. So the thing that we're looking for here, by the way, is that we're having a problem on premise. We're running out of space. In addition, we need to support all three types of storage because we're having tons of problems with optimization of storage. And we know that storage demands are only going to increase. How do we do this in a way that allows us to optimize our storage? What we're looking for here is that we want to optimize storage costs while still maintaining high availability. We want to reduce the cost of storage for images as they age. I can't tell you how much stuff I have in my Google Drive that I'm like, I actually just need to go through here and purge this thing, you know? And then how can you automate like a purging process or some kind of at least like data classification process so they can make it cheaper? And then what are some options to build scalable storage for with Windows and Linux? And then I need to move to the cloud. I need to move my storage to the cloud. I need to move my data to the cloud. How can I do that? There's some options here. I'm not talking about databases, by the way, just data. So the thing we're emphasizing here, this is a little contrasting, by the way, is that we're talking mainly about everything that's going on here with RDS, and we're talking about everything going on here with S3. S3 is object storage. EFS is file storage. We already talked about block storage, right? That's what the elastic block store is for, right? It's block storage. We also talked about instant storage. That's what the instant storage is for. That's block storage, okay? So we're going to talk about these solutions. Now let's just talk in general about storage services. So first of all, what am I going to do? I'm going to wreck your brain by basically showing you all the possible associates to storage services. But here's what I want you to do. I want you to ignore everything on this drawing except for this, right? That's it. And why did I use the square? I don't know. I clicked on a circle actually, so just roll with it. By the way, we've already talked about this one. We already talked about EBS. So really, we just need to talk about these two. And this is actually one service. Once again, Amazon is touting Glacier as a separate service. And I can see that, like in a sense, like I could see that they might consider it that. It's actually all S3. That's S3 Glacier. Okay, so it's just S3. We don't usually like treat Glacier like it's a separate product. It is a subsystem inside of S3 from our perspective. The rest of this, as far as like transfer acceleration and direct connect and data sync and all that stuff, we're going to talk about some of these, but most of this you don't need to know. Like, people aren't generally going to touch QuickSight. Macy is the security tool. The rest of this we're all going to cover, or we've already covered in separate sections. Okay. So don't get all wrapped up in this complication. We're just going to talk about EFS, FSX, and S3, 3 services. And we might talk about storage gateway. Oh, and we'll probably talk about the Snow family. I got to tell you, Amazon really loves the Snow family, especially Snowmobile, which really just, it's weird. We're going to talk about it. All right, let's talk about S3. So S3 is the object storage service. What do you put on S3? Basically, S3 is Amazon's data dump. If you're like, we want to keep it, but we're not really sure, and we think I have this discussion with machine learning and data scientists all the time. My goal is to give data scientists and machine learning folks as much data as they want. Why? Because if I give them the right data, and it can be like deduped and normalized and all that other stuff, then I can give them the kind of data that allows them to train their models to do like all the inferences and other things that they need, right? But if I don't give them any data, then they're not going to get anything. It's going to, and no one's going to derive any value, right? So the cool thing is that I've been doing this since 2013. Is that when I get like clickstream analytics data or website data or whatever data it is, I just like dump it into S3, and then I will, if no one uses it, I'll step it down to the cheapest storage possible. But then when all of a sudden, the data science team is like, hey, we're doing analytics against the user behavior for this particular product, I just pull it out of storage and throw it in. To say this, S3 has 6 different tiers of hot to cold storage. And so basically you use it for anything that you need to retain data for, and you want to keep it at a low cost, or if you want to like share like video files or image files or whatever, and you want to maximize the availability, because you can't do that really well with a web server without like really hammering the web server. S3 will scale to thousands, if not tens of thousands of simultaneously available shared files, and it won't break a sweat as long as you're not expecting super high performance. Like, you're not going to run a database off of S3 because, first of all, it's not going to mount inside your operating system, but it's great for just a broad data dump. You want to share a bunch of image files? S3 is great for that. You want to share a bunch of video files? Put CloudFront in front of it. S3 is great for that. So you want to retain every single log file you've ever generated, even though like probably like half the company is not even ever going to look at it, but you want to keep it for compliance purposes or whatnot. Great. Throw it into S3 and then throw it into Glacier, right? So just know that this is a great data dump for just storing any files that you need to retain. Now, the other cool thing about S3, right, is that a lot of people use it for backup and restore. I just mentioned archiving and compliance. It's great for security, by the way, because you can actually create a worm model here and write once, read many times, and you can lock that file and nobody can change it ever. Like, you can lock files in a way that no one can undo it, not even the administrator of the account, right? So really great for data dumps of any type. Now, the thing you need to know is that S3 operates in this concept called buckets. That bucket is, think of it as like a high level folder. All of your objects go into the bucket, and you can put subfolders in there, but they're not called subfolders. They're called prefixes. Why? Because this is not a file system. It just looks like a file system. They're just messing with you. Every object you stick in here, by the way, gets a URL attached to it. Okay. Sorry. I was gonna just show you my, oh man, I was gonna show you my S3 bucket, right? So S3 is basically homed in a particular region. So just know that you have to pick, when you create a bucket, you have to a particular region. The other thing that's a little weird is that when you use S3, you have to make sure that your name for your bucket is globally unique. So just know that when you like create a bucket and you're like, hey, if you try to use a bucket like my favorite bucket, that's not going to work. S3 is 15 years old. People have created buckets for almost everything you could think of. I started putting goat in the name of everything just because I was certain that nobody would be using goat for like, right, for anything. And I was wrong, by the way. People were using goat for a lot. So So here's an example. Let's go to S3. So if we go look at S3 as a service inside the console, the first thing you're going to notice is that notice in the upper right-hand side, it now says global. It doesn't say the region. Don't be fooled by that. Buckets exist at a regional level. They're just managed globally, which is why it says global on the upper right-hand side. Now, notice I got like test goats and new goats bucket and stuff like that. I've got a file in here called BAH admins, and this contains things like Kubernetes stuff, right? Presentations, different things like that. Oh, MechWarriors mods. You know, I still play video games with my nephew and my son. Sometimes it's the only way I can get them to talk. So notice that there's like links in here. If I click in here, like say 2919, and notice there's like some VM files you can download. If I click on one of these, it automatically has a URL that can be accessed. And that bucket's the only wide open bucket I have, actually. There's nothing proprietary in here. You can steal my virtual machines if you want to. The point being is that notice that this looks like a file system. There's a 2019 folder, it looks like, and then there's the bucket BAH admins at the top. But that's an illusion. These are prefixes that are attached to the object in question. It just pretends to look like a file system, make it easy on our human little brains, right? That's all. Notice also that some of these files are actually in what's called the standard storage class. Some of these are in one zone in frequent access. This MechWarrior mods is actually in Glacier Deep Archive, which is kind of funny. And then there's a simple greeting like file here that's just in standard as well, right? So just note that within the same bucket, you can have objects inside that bucket that are actually in different storage classes. Some are hotter and more expensive, and some are colder and cheaper. So this is how this works. Now, notice that you've got a bunch of other things in here like bucket versioning and properties and encryption. There are all kinds of permissions that you can set off. Notice that this is a resource policy. Notice the principal here. Principal is a star, which means anybody can access this bucket. They can read it, get an object, as long as they're accessing 2919. Notice here that if there's any metrics as far as objects, right? Any management, like lifecycle rules or whatnot that need to be happen. And if I want to create any aliases, you can create access points, which allows you to create a new bucket name that actually points to the original objects inside the bucket. So they now have aliases with these access points that you can use with S3. Notice that this lives in a particular region. This is in US East 2, Ohio. I've got others in North Virginia. I've got a couple down here that might be in Canada Central. Oh, hey, look, there's the DevOps Cyber Club. And then, you know, I think I got rid of all my Oregon buckets because I wasn't really talking a whole lot to the West Coast. So there might be one or two floating around here. Oh, wait, here's one. That's for Beanstalk. I didn't even create that one. All right, so remember that buckets live regionally. They have a home at a regional level. And Amazon does, by the way, highly replicate them. So, you know, this has 11 nines of durability on it. 11 nines. I think it means it's going to take them 10,000 years to lose one of your like 100 files or something like that. Something ridiculous. So, yeah. So that's a little like showcase of how S3 functions. Now notice that in the URL, by the way, there is the name of the bucket, and then there's the object key and its prefix. As we go forward into this, just know that you can make buckets public, private. You can like control who has access. You can make it so that CloudFront is the only one that can talk to the bucket, even though the bucket looks like it's publicly available, but it's not. Only CloudFront can talk to it. Because Amazon kept showing up in the news because people are like, once again, Capital One decided to share their entire social security number history for all their customers with the world through an S3 bucket. Amazon added an extra firewall called block public access. You have to disable like 2 or 3 things in order to get your bucket available to the world, because they're really trying to make sure that you know that you're about to do something dangerous and share it across the internet. And you kind of think like, hey, people don't need access to, you know, sorry, people, you know, can't find these URLs. So through obscurity, we're going to hide our S3 buckets. I wouldn't rely on that, right? So Amazon added this extra firewall to S3. to prevent you from sharing things that you didn't intend to share. Now, in addition to some firewall controls, you can actually turn on versioning for your files. So if you have a file that's very precious to you and you want to make sure you track who edits it, or you just want to make sure that nothing's deleted, because nothing really is deleted with versioning. You have to explicitly go in and delete every single version, including the delete marker, if you want to delete a file. But anytime someone uploads a new version, it just increments it. So be careful with this, because I was running a video company and someone turned on versioning on a 3.2 petabyte video file bucket. And all they were doing was updating the metadata of the files. And the files averaged about a gig in size. You can do the math on that. Next thing you know, our storage costs went from like $10,000 a month or something to like 15. We're like, what happened? Someone turned on versioning. And so every time you modify a file and upload a new version, it's going to make a new copy of the entire file, not just the changes. I've mentioned this several times. So in addition to turning on things like versioning or MFA delete, by the way, which requires a multi-factor token to delete anything, which is kind of cool. The other thing that happens is that you can go to any one of the 6 storage classes, of which the ones on the left are super hot, the ones on the right are super cold, which is, by the way, why they're called Glacier. Here's something you need to be very, very mindful of. Once you cross the line from one zone in frequent access over to Glacier, your files are archived and they are no longer directly accessible. So if someone asks you a question and says, hey, you'd like to archive your file to colder storage and it's going to be infrequently accessed about 2 or 3 times a day, you are not going to use Glacier. Because if you go to Glacier or Glacier Deep Archive, that file is no longer directly accessible. So you have to restore it and then you can access it. When you restore it, by the way, it gets kicked into one of the other storage classes. So I just want you to be mindful of that, is that as you go to colder storage, it gets cheaper and cheaper and your access is supposed to be greatly reduced. But once you cross the line into Glacier and Glacier Deep Archive, it's actually archived, no longer directly accessible. Now, the other thing that's a little weird about these storage classes is that standard is standard and it's super hot, fast storage. Standard infrequent access, which is in the middle, the standard IA, that is still very redundant storage, but you're only going to access that like, a few times a day, maybe a few times a week, right? One zone infrequent access reduces the redundancy, but you're still only accessing it, a few times a day, maybe a few times a week. Intelligent tiering, by the way, is super strange. I don't know why they have it here as a storage class. I feel like it's more of a storage option. If you turn on intelligent tiering, Amazon will move your file to any of the other storage classes based on its access pattern. So if you don't know what your access pattern is going to be for your system and you want to get the cheapest storage possible, turn on intelligent tiering. What will happen is it will move it to colder storage based on the access pattern. So intelligent tiering is a machine learning derived algorithm that says, hey, this file hasn't been accessed in 30 days. I'm moving it over to infrequent access. Hey, this file hasn't been accessed for 90 days. I'm going to stick it in a Glacier. Hey, this file hasn't been accessed for 180 days. I'm going to stick it in Deep Archive. So just know that intelligent tiering is a little different from the other storage classes in that it will actually move files to different classes based on their access. Now, Glacier is usually 1/10 to 1/20th the cost of standard storage. But a reminder that Glacier removes that file from direct access. You got to restore it first. Now, restores take anywhere from 5 to 12, 3 to 5 hours. So 3 to 5 hours to restore, 5 to 12 if you do bulk retrieval. They do have what they call expedited and instant retrieval. You're going to pay a per gigabyte charge for that restoration. So just be careful of that. And just so you know, there's no storage limit to the maximum amount of storage you can store in S3 or in Glacier. So if you want to put exabytes of storage or whatever in there, totally go for it. You can. If I ever win the lottery, by the way, know that I'm going to be dumping a lot of data on Amazon just to see how far we can go with that. So, sorry, that was a maniacal laugh. When you use Glacier, by the way, it actually has the concept of, instead of buckets, it uses what they call vaults, and archives. These files go inside vaults. Now, S3 caps out at a 5 terabyte file size as the maximum. Glacier caps out at 20 terabytes as the file size maximum. So just know you've got more options with Glacier in terms of size, but be very careful with uploading a 20 terabyte file. Make sure you've got some kind of consistency check, CRC, whatever, to make sure that that thing has some kind of internal structure for recovery. Otherwise, that could be problematic. Here's, by the way, the retrieval times that I was talking about. Bulk is 5 to 12 hours. Standard is 3 to 5. Expedited is 1 to 5 minutes. There's also a new one that just came out 2 weeks ago called Instant. I want to say that's like less than a minute or something. So it's not instant. It's fast. I don't remember. I think at one point they were like, it's like 3 to 5 seconds. I was like, it's less than a minute. Word of caution, bulk is free. Standard is like 1 cent per gigabyte. Expedited, I want to say, is like 3 cents per gigabyte. And Instance, I don't even know what that is. I think it's probably like 4 or 5 cents per gigabyte of restoration. So just know that other than bulk, you will actually pay for restores inside of Glacier. And there's time limits here. Like, it needs to stay in Glacier for 90 days and Deep Archive for 180 days, or they're going to charge you a early retrieval fee as well. So read the fine print on that. You're not going to be moving files in and out of this thing unless you use intelligent tiering, right? So just be careful. A small amount of data movement isn't going to hurt you. If you do start doing a moderate amount, you're going to start seeing charges rack up and you're going to be wondering what's going on. So make sure you understand that they want you to keep these files in Glacier for 90 days or 180 days before you restore them, or they're going to charge you a fee. It's pennies, but still. Other thing other than Glacier is that if you want to set lifecycle policies that says, hey, if this file is older than 30 days, move it to standard and frequent access. If it's older than a year, I want you to move it to deep archive. Or, hey, if it's older than 18 months, I want you to delete it. Or if it's older than 7 years, I want you to delete it. So just know that you can set up lifecycle policies that can transition objects, not just to another storage class. You can also delete files as well. There are 3 ways that you can do encryption at rest for Amazon for S3. There's SSE S3, which is S3 based encryption. There's another one where you can use the key management service called KMS. And there's another one where you basically submit a customer managed like primary key to Amazon. I gotta tell you, I probably would just use KMS if you have a chance. If you have compliance requirements that says you must control the key, I got just so you're forewarned, the customer managed key is actually persistent on the system, on Amazon's system for a few minutes. It's in memory over there. So if you need to fully control the key, then you should encrypt the data before you stick it out on AWS. Just throwing that out there. Just know your requirements. You can also, by the way, take a bucket, turn on versioning, connect it to another bucket, and it will replicate objects with that bucket. So you can actually create replication between what's going on in your bucket with another bucket, and it doesn't have to be in the same region. It can be the world over, right? Great way for copying backups, by the way, for keeping backups, copied over to another portion of the world. The other thing that's cool about S3 is that you can trigger notifications. So if you want S3 to trigger a video conversion or an image conversion or an email or a write to a database, once it pretty much hits Lambda, you're done. You can do anything you want at that point in time. You can call any API. You can manipulate it any way you want to because Lambda is just code. By the way, the S3 bucket will submit the file name that you're triggering off of and whether it was added, modified, deleted, whatever you want to like put up there. And so just know that you can set what's called S3 event notifications. In addition, other features that are kind of appropriate here, in addition to being able to tiering through life cycles, going through different like storage data classes, in addition to triggering Lambda functions to do things on your behalf, is that you can also enable CloudFront in front of S3. So if you want things to go faster when people are uploading files, you can turn on CloudFront. CloudFront will intercept the upload and then run it over Amazon's high-speed backbone faster than over the internet. The other thing that's cool about this is that S3 has an FTP server as well, and it used to have a BitTorrent server. I just found out because I saw a retirement announcement that says, hey, S3 for BitTorrent is going away. And I'm like, is that a thing? Are we still torrenting? I guess we are still torrenting. I didn't think that was a thing. Anyway, so you can do transfer acceleration as well as SFTP using S3. The other thing that can help with uploads is that they have this thing called multi-part uploads. This, by the way, is only really useful if you're not using your full bandwidth because you have some kind of process constraint. So, I mean, if you're already at 100% utilization for your network bandwidth, I don't think adding multi-part upload is going to make a difference. But one thing it can do, particularly if it's a large file, it'll allow you to do the large file in chunks so that if it gets interrupted, you can just re-upload the missing pieces, and Amazon will actually put the file together on their side. So they'll actually hold on to all the chunks that you send them and then reassemble the file once you send all the parts. So this can be very useful, not just if you want to maximize bandwidth, but sometimes when you have spotty or choppy bandwidth, it'll allow you to upload pieces at a time and then reassemble them. Pause and resume object uploads. You can actually stream a file that isn't fully formed. So for example, let's say you've got half of the file, you can start streaming it up and then has the other half is created and it's added. The multi-parts will then grab the rest of the parts in question. So this is obviously a command line thing. So you're gonna have to mess with the S3 CLI to get this to function. And you can specify the number of parallel parts you want to break it into at a time. Then we talked about access points a little bit already. It has aliases into the objects that are inside an S3 bucket. They do have their own kind of resource-based policies, so you can actually add more policy differentiation if you want to. This does not actually point at the bucket, but it points at the objects that are inside the bucket. So you can't manipulate the bucket using access points, but you can manipulate the objects that are inside the bucket. So just keep that in your back pocket. Think of this as an alias to your existing bucket. Now, this is actually pretty cool, something they added recently. So with Object Lambda, what happens is that if you go to access a bucket, what it will do is it will trigger a Lambda function to do something to the file that you're pulling. For example, it could redact all the social security numbers and sensitive information out of the system. That's pretty cool, right? You can compress and decompress files. You could add data. You could remove data. You could obfuscate data that you don't want to share. So, you know, this can be a great way to manipulate data that you're pulling out of S3 by scrubbing it or adding something to it before you send it to its final destination. Now, things to think about that will come up on the exam. You pay for any data that you host in S3. Putting it into S3 costs you nothing. Taking it out of S3, you're going to have to pay for. But here's the catch. If you're pulling it out of S3 into CloudFront, you're not going to pay anything. If you're pulling it out of S3 and you're in Virginia and you're using a virtual machine in Virginia to pull out the data and the bucket lives in Virginia, you're not going to pay any money. So if you're in the same region or you're using CloudFront, you're not going to pay any money to pull stuff out of S3. Otherwise, you're going to pay. So if someone downloads 3.2 petabytes of data and they're in Australia and you're in Ohio, you're going to pay for that. So this includes all API calls, any data you pull out that doesn't meet those other criteria, and the number of gigabytes hosted as storage per month. There's other criteria, by the way, that you kind of need to consider. If you need to figure out pricing, I'm just going to show you this really quickly. There's actually two calculators. There's the simple monthly calculator, which everyone is still madly in love with, which is why Amazon can't get rid of it, right? And then there's the calculator.aws, which does things like estimates, right? So you can come in here and turn on your storage class, right? You can actually set your standard storage. But the reason I like the simple monthly calculator is it will teach you the questions to ask. How much storage? How many basically like uploads? How many reads? Like basically this is like how many changes, right? This is how many like reads. And then if you're using the S3 select, which is a particular subservice that does like inventory, you can, add that cost in. So if you want to use intelligent tiering, another set of questions. You want to use infrequent access, another set of questions. One zone, another set of questions. In other words, this will teach you the questions that you need to ask in order to figure out your costing. You might come in here and say, look, I know I have a terabyte of data, and I know I'm going to make 1,000 changes per month. I'm going to read this about 10,000 times, right? I'm going to do about, let's say 100 lifecycle transitions. And, I might retrieve about, let's say 10 gigs a month of data. We go, look, guess what? $10.37 to host a terabyte of data with those characteristics under one zone of frequent access. So these are the kind of questions this can answer for you. To see that, by the way, the difference in price for 1 terabyte of data, I'm not going to change anything else, but let's just do 1 gig actually. Well, actually, let's do a terabyte because it's not meaningful. So $23.44 for 1 terabyte of data on standard S3, right? If I go down to intelligent tiering, by the way, notice that, because intelligent tiering, by the way, requires you to answer all these other questions to really understand what your price is going to be. So intelligent tiering actually operates really differently, but look at this total cost. So it's about the same, but a little bit more, right? So it was $23.56 here. If I look at it up here, it's now $23.44. So intelligent tiering was a little bit more expensive with no transitions. Now, remember, you got to put this stuff in here in order to get cost. Intelligent tiering doesn't really match any of these rubrics. But we saw that it was $23.44 for standard storage. Let's say we come back down here to infrequent access and we add a terabyte here. How much is that going to cost us? Whoa. Did that just go from $23.44 to $12.80? So almost a 50% drop, right? The minute we drop down to infrequent access. Let's get out of infrequent access. Let's go to infrequent access one zone. So that's 1024. So that's greater than 50%. Now let's go down to Glacier. $4.10 for a terabyte of data. So we went from $23.44 to $4.10. That's like a sixth of the cost. Is that accurate? It's pretty accurate. Now let's go down to deep archive. Let's say we put a terabyte down here. So we drop down and all of a sudden it's $1.02. So what this should do is it should give you a feel for why people want to do lifecycle rules and why they want to use intelligent tiering and why they want to stick their data in the appropriate tier. Because if it's 1/10 of the cost, in this case, what is that? 1/23rd, 1/24th of the cost? That's a significant change. So remember that simple monthly calculator is where you're going to go in order to get the questions that you can ask to find out what things are going to cost. I do want to note also that EC2 is over here, Route 53, CloudFront. There's a bunch of services over here. If you need the other services, if you click on this link, right, it'll take you to other things like EventBridge. So it's going to take you to the calculator that I was just looking at before. So between these two sites, calculator.aws and the simple monthly calculator, you pretty much have everything you need to do these calculations. Cool. Questions? Okay. So here's some best practices, and then we're going to take a short break. So the best thing is that make sure that you're either using intelligent tiering or your lifecycle rules, because if you don't, you're gonna be paying full price for something that you don't need to pay full price for. Make sure that if data protection is of earnest to you, you can turn on versioning, you can turn on MFA delete, you can replicate your data, which by the way, does turn on versioning to other regions. So if you're worried about that, and then know that even outside of the security tools that are available outside of S3, they've got the block public access firewall. You can turn on encryption. You've got access points and object ownership that you can actually vary and change to make sure you have different aliases and different control policies. And then between CloudWatch, QuickSight, S3 Select, you can get a number of insights about what's going on with your S3 installation. Now remember, when you've got a variable data set of just files that you just need to hold on to, just know that S3 is just a great use case for any kind of data dump that you need. There's a class actually called building data lakes in AWS, and it uses S3, right? Using lake formation, it uses S3 to build the data lakes. Questions of any type?
Yeah, hey Michael, I was curious, does it make sense to do antivirus scanning for objects in S3?
Well, the problem is that doesn't make sense is subject to whatever security policy, right? Now, whatever security policy you have to deal with. Now, if let's say, that's really hard to answer. I would say in most cases, you probably do want to do file scanning, especially if it's going to be shared and available out to other people. As far as like acquiring a virus while it's on S3, no. It either acquired a virus while it was put up there, or it acquired a virus, on the way down, like it hit an operating system. But I gotta tell you, if it was clean on the way up there, it's not going to acquire a virus in transit, right? But that if you don't know who's changing files, then it might be worth actually doing the scan. I don't know. It's kind of a hard thing. It's like I used to say, like, for example, Mac OS and Linux tended to be harder operating systems to, crack and get viruses for. But like Mac OS is so full of holes, and Linux has its own problems. And hackers love going after Mac OS because it's got a better client profile, right? As far as like who uses Mac OS, it's usually tech workers, right? And it's usually people with, anyway, they're more attractive to hackers. So my point being is that it really depends on your policy, but it's not going to get infected on S3. It's going to get infected by somebody putting it on S3. So, yeah. And the reason I have mixed feelings about that is that I love the security that kind of like process provides, but it can really slow things down tremendously. So it's always that kind of like thing of like, well, we need to protect our assets. So what is the minimum thing that we can do to make sure this is adhered to? But then, you start file scanning everything, like a 20 terabyte archive. Can you imagine doing a virus scan against a 20 terabyte archive? But it might be necessary. So, yeah. So I think the answer is in your environment.
Sounds good. Thank you.
Yeah. Other questions? Cool. Okay. So let's pretend it's 9:55. Let's come back at 10:05. We're going to finish out the EFS kind of FSX story, talk about some Snow family stuff, and then we're going to be done with storage. So 12 minutes from now, so 10:05, we're going to be resuming. Okay. So we'll catch you in a bit. Okay. Questions about object storage, about S3 as a service, versioning, lifecycle policies, the different storage classes. Okay, Let's talk about file storage. It's very easy for us to fall behind on patching. Are there managed options for file servers in AWS, right? In other words, can we get away from having to manage our own NFS and Windows file shares, right? Now, with shared file systems, right? You know, EBS volumes are limited to a single availability zone, and you know, you can have up to 16 attachments, right, to a single OS, right? Object store could be an option, but not if you want any kind of performance from it, because while it handles like multiple like web-based connections really nicely, having an EC2 virtual machine or a series of EC2 virtual machines all sharing the same files in a file system, you can't do that with object storage, because object storage does not mount inside of the OS, right? So EFS is going to be your like perfect option for those kind of scenarios. Now here, right, we've got EFS as an option. This is NFS version like 4.2, if I remember correctly. And this is going to go across availability zones, regions, VPCs, and accounts. So it can share, across a bunch of different like possibilities. So you could share between thousands of EC2 instances. You can share with on-premise servers. You could do read-write, read-only data, right? It can be accessed concurrently. Notice that it sends a mount target, which is basically an IP address in each of the places that it's going to exist in. And then you access or mount that IP address as if it was an NFS server, because it is actually. So EFS is really nothing more than just NFS. You got 4 nines of availability. You can do cross-region snapshots, right? You can manage it with AWS Backup, which is a tool we're going to talk about here towards the end. You can auto scale or user define the throughput if you want to, but it has 11 nines of durability, just like S3. Now, setting it up, you're going to get like a file system ID and a domain name, right? That you then can use to resolve no matter where the EC2 mount system is, right? So the mount targets and EFS are actually highly available virtual devices inside the availability zones across an entire region. So so EFS is a regional service, a little different. So no single points of failure. So no real re-architecting required. You just use your NFS client to mount these systems. Now, that was all pretty much Linux based, even though you can get Windows to mount an NFS system. If you're not native, like especially if you need like integration with like directory file services, data duplication, Active Directory type integration, you're going to be using the Windows file server. And this is FSX for Windows file server. Now be prepared. There's actually 4 flavors of FSX. There's FSX for Windows. There's FSX for Lustre, which Lustre is not just for Windows. That's a high performance computing file system. And then they've got FSX for ONTAP, which is like NetApp's proprietary file system. And then they've got FSX for OpenZFS, which is actually, I think it was originally a Solaris thing, if I remember correctly, the Sun Solaris. But it's an open source kind of high performance file system. People really love it. So just know that there's lots of options with FSX for Windows. Now notice here that this is running across, right, availability zones in this particular case. So thousands of these compute instances could access this SMB CIFS file share, and you can access it through VPC peering, transit gateway, all the other stuff. This is using NTFS as the file system. It does have Active Directory integration. It will use the distributed file system, the DFS, right? And this is all, CIFS and SMB based. Supports SMB3. Now, Lustre is an SSD based version. This basically will also allow you to connect. This is a single availability zone though, just to mention this. This is for high performance, computing, right? So this is when you need to write a lot of throughput really fast to a shared file system with a bunch of compute instances that are all connecting to these ENIs, right? So this is a very specific scenario. Lustre is a very specific file system for a very specific use case. By the way, Lustre will also happens to mount, like you can actually put mount points inside of Lustre that will write to S3. Do not expect a lot of processing speed like for that, but it is a way that you can like write data files out to S3 directly using what looks like a file system. ONTAP and OpenZFS are relatively new additions, so they're not included in the slides yet. A little bit more refinement, but they'll probably be there in 2022. Now, that was just EFS and FSX really for Windows and FSX for Lustre, but EFS is really the key player there, and FSX for Windows is the other key player. Now, that all being said, what do we need to do a data migration? What are our options? Well, if you need to do it offline, AWS has the Snow family. I don't know why that reminds me of Game of Thrones. No, they have the Snow family, but they also then have things like data sync. They have the data center migration service. They have the server migration service. They have the database migration service. They have the application discovery service, which isn't really a migration tool, but still, you can at least discover what's there. And like those are great like services whenever you need to migrate data. They're not really talked about a whole lot here, but just know that Amazon has a whole suite of migration services over and above kind of what's here. Now, the storage gateway and data sync and the transfer family, those are just tools that are used to shift data back and forth. Storage gateway in particular, though, is interesting because it's really used for on-premise shifting of data from on-premise into cloud. So kind of an interesting little tool there. It's a virtual machine that runs inside your data center, and it either acts as a tape drive, a file server, or a disk server, like an iSCSI, like volume server. Well, let's talk about the offline stuff first. So Snow Cone, Snowball Edge, and Snowmobile are considered like we're going to move data into AWS. Snow Cone is just a little confusing because Snow Cone, I think, only has like 8 terabytes of usable storage. And so it really isn't used for data transfer per se. It's more like an edge computing device. Now, the Snowball Edge and the Snowmobile, though, are slightly different in that the Snowball Edge comes in several flavors. One is like compute focused and one's storage focused. But that device can actually transfer, I think it's 73 terabytes usable. So they say 80 terabytes of space is transferable with the Snowball Edge. So you can get 10 of those together, you know what I mean, and transfer quite a bit of data into AWS. And the turnaround's only a week or so. So, you know, a couple of days for you to get it, a couple of days for data transfer, a couple of days to set it back, right? The Snowmobile is a giant truck, and I felt like I was in maximum overdrive in 2016 when I went to reInvent, because this truck just showed up everywhere we went. First, it was on stage, although why you would drive a truck on 20 feet on stage was a little weird. Then it showed up in the vendor hall, and we're like, how did they get this truck in here so fast? I think by the time we walked from the main showcase out to the vendor hall, they had already moved the truck in there. I was like, man, really got their stuff down. Anyway, the Snowmobile, by the way, will only transfer 100 petabytes per Snowmobile. So they call it an exabyte scale data migration service, but let's be super clear. Each of those trucks only holds 100 petabytes, which is still a lot of data. So you're going to need at least 10 of them in order to do an exabyte. This, by the way, comes with an escort. It sits outside your data center. It hooks into your data center via, whatever networking you can support. And this is what you use in order to send and transfer exabyte level data, right? So just know Amazon thinks about the Snowmobile as an exabyte data transfer, and they think about the Snowball Edge as a petabyte data transfer, even though both of these devices do one step down. Snowmobile does petabytes, Snowball Edge does terabytes, right? So something to be aware of. Now you order these off of the management console, they get shipped to you, you fill them full of data, and then you can ship them back and they get copied up to your S3 bucket. So these are actual devices that you're going to ship up. So they go back to Amazon and Amazon copies them back. So this is why this is an offline process, because this isn't going to happen in real time. You put your data there, you give it to them, they upload it. Now compare that with data sync. Data sync will run an agent like on one of your clients, which will then pull in all your files off a file server and then put them onto S3 or EFS, right? So this, by the way, can be used as an ongoing backup or as part of a migration task, right? This is a service, so there's no servers for you to manage. You just install the agent and it takes care of it from there, does security transfer back to AWS. So this one's online. And then there's the virtual machine that I was talking about, the storage gateway solution, which, by the way, this does figure heavily on the exam, just so you're aware. What this does is this allows you to run a virtual machine in the corporate data center and copy those files back either to S3, to EBS, or to Glacier, depending on what mode you're running in. So here it's in file gateway mode and it's copying back to S3. But as I said before, you can use either NFS or SMB for this. So that file gateway will either run NFS or SMB in order to talk to, like, to feed out files. But as I said before, remember, this has a file version, a volumes version, and a tape version. Note that 2 of those are using iSCSI, but the file version can either use NFS or SMB as its like transfer protocol. Note that that virtual machine runs on the customer premise, replicates back to what's called the storage gateway service, and it can dump in any of those 4 different data repositories that you see there. S3 and of course Glacier, EBS and EFS. It just depends on what you choose for targets. Now, usually for tapes, it goes to Glacier. For iSCSI volumes, it could go to EBS. And then usually for NFS or SMB, it's going to go either to EFS or to S3. They are going to ask you questions. They're going to say, I got a scenario where we need to run, we're running out of tape space. Is there a way for us to use Amazon to extend our tape drive capacity up into the cloud? The answer is going to be storage gateway using the VTL for iSCSI for tapes, right? Virtual tape library, VTL, virtual tape library. So know that these are options to transfer data and migrate data out to AWS. Don't forget also is that there are other options as far as database migration service, the server migration service, the data center migration service. There are other migration services out there. But data sync, storage, the storage gateway, and using the Snow family are all appropriate. As far as like the other things they mentioned on that first page, the S3 transfer family, SFTP, sure, you could do that. Probably gonna look at a faster option though. Okay, let's do a little knowledge check. According to Amazon, which of these is a petabyte scale data transfer solution? No, I said petabyte scale, not exabyte scale. Petabyte scale. That's why I said according to Amazon, not according to Forrester. We know what the reality is that the snowmobile can transfer 100 petabytes, right? But according to Amazon, that's an exabyte scale device because it can do 100 petabytes. Why? I seriously don't know. But the answer they're looking for is Snowball Edge. So if you get an exam question and it says, hey, I need you to choose a petabyte scale device. If it says petabyte scale, then they're talking about the step up. If they say, hey, I need you to transfer 80 petabytes, then by all means, you're going to answer snowmobile. So that's the right answer. But if they say, hey, I need you to transfer 70 terabytes, you're going to use Snowball Edge for that because it's 80 terabytes. In theory, it's 73 terabytes usable. Okay. So just remember that if they use the word petabyte scale or exabyte scale, they want you to step it up to the next device. If they just say, hey, I want you to transfer this explicit amount, then use the right device for the explicit amount. Okay. I know it's confusing. I'm just giving you a heads up. Okay, which Amazon S3 feature can force an action to occur after an event takes place within a bucket? Good. Event notification is indeed how you actually trigger a response from like a Lambda or an SNS or whatever service you want to integrate with. We've got two Linux applications in different availability zones that have to share a common file system. What solution do you have to use for Linux for them to go across availability zones to share a common file system? Now, if that said Windows and different AZs with a common file system, then the answer would be FSX. But otherwise, D is definitely the right answer, right? EFS. Okay. Which of the following protocols are options with the Storage Gateway Virtual Machine Appliance? What are 3 of the different protocols you can use? One of them covers the whole like volume and tape version, and then there's 2 protocols that are attached to the file version. Good. So iSCSI for volume and for tape library, and then SMB and NFS for file server sharing, right? Just know that like FTP, the file transfer protocol, that's only with S3. Fiber channel over Ethernet and fiber channel, those are low-level protocols, and Amazon does not offer those, as far as I know, in any version of anything. So I'm sure they're using them, but they don't offer them as a service. Okay, that is the end of module 5. Any questions of any type?
So could you briefly talk a couple of sentences on EFS one more time, sir, please?
And why don't you ask me a specific question there? What is it that you want to, what you want to know?
So I missed that part of the talk.
Oh,
Sorry.
but so EFS basically is just NFS. That's all it is. So NFS is used as a network file share, so you can actually share volumes out with other systems. It operates at layer 7. And basically what happens is that Linux boxes will actually mount that share as if it's part of the file system. Even though once you CD into that portion of the file system, it's actually on a remote system. And so that's how you can actually share file systems at a high level between each other. And EFS is the service that Amazon basically took the NFS protocol and made it so you could actually share it with thousands of systems across an entire region. And so that's all it does. It's literally just NFS version 4.2. I think it's 4.2 is the latest. So that is in MS version 4.2. And so it's highly Linux compatible. You can get Windows to mount NFS, but typically it's built for Linux systems.
What is the underlying storage for this?
We don't know. It's a managed service.
It's managed service, gotcha.
Yeah, it's a managed service, but just so you know, it's got 4 nines of availability and 11 nines of durability. So I suspect it would be S3, but they won't tell you.
Mhm. Yeah, that matches with the S3, right?
Yeah, it does. Yeah. I feel like they're putting a server on top of S3, but just so you know, this will actually go way faster than S3 ever will. So you can actually turn the dial on performance to make it go fast.
Gotcha. Thank you.
Yeah. All right. That is the end of module 5. By the way, my system involuntarily rebooted because that's what needed to happen. So notice I can go full screen now. All right. Let's talk about database services. Note that there is a lab with this database service. Let's take a look at this really quick. Not that one. Let's go take a look at this one. Let's turn this thing on. Let's do a little pre-warming. We're gonna do a lab. Did it log me out? It did log me out. You're always logging me out. All right, just making sure that we're on track, and we are. Good. Okay. So we're gonna talk about databases. When I say we're gonna talk about databases, let's be remarkably upfront. But first, hold on, let's do this.